In this session, we will be dealing with how to work with the math function. And for this case, we have taken the trigonometric uh, sine quantity with respect to the several angles. So here we can see that when the angle is 30, and first of all, we have to understand the relationship between a pi and a degree. We know that pi is equivalent to 180 degrees. That means for any arbitrary angle A, the resulting pi factor according to degrees would be that A multiplied by pi divided by 180. So that has been taken up by this particular factor here. Now, once that has been done, the whole of the factor has to be put inside the math function with the help of the sine, calling of the sine method with respect to the math class. And we have to enclose the whole object of A multiplied by pi divided by 180. So here this step is same as the step here. Both the step means the same thing. So this will give the factor of sine 30 degrees, that is nothing but 0.5. And the secondly here A is taken as 45. And the sine of 45 is nothing but 1 by root 2. So that will be displayed by this particular line. And thirdly, we are taken as sine 60 degrees. And with respect to 60, we know that sine is approximately equal to root 3 by 2, and that will be displayed by this particular line here. And for sine 90, now we have declared a particular quantity of values from between 0 to 90 degrees. That is been taken up by the incremental for loop. Starting value I0, then I plus plus taking up to the value 90 degrees. So we are intended to get the whole of the display of the factors for the angle of the sine, starting with the value 0, then till 90 degrees, and is displayed by this particular sentence, this line. So we know that I is an incremental factor, and that is possessed by the math function sine of the math. So it will display each of the factors of the incremental value of I, starting with 0 till 90 degrees, and whole of the stuff will be displayed in an incremental for loop. And the same has been displayed for the tan angle starting with 0 to 90 degrees. And thirdly, and the fourth loop will be displaying all the values of 0 to the 90 degrees with respect to the cosine function. So we see that for the first for loop is displaying 0 to 90 degrees with respect to sine function. The second for loop is displaying 0 to 90 degrees with respect to the tan function. And the third for loop is displaying all the 0 to 90 degrees with respect to the cosine function. So let us discuss each of this one of them after the other. So we go for the start button for the display of the whole thing that is taken up. So we are going for the browser page where exactly we get into the output. So we can see here that a set of all the inputs have come up. So starting with the value that was sine 30 degrees, that was 0.5, half. Then we look for sine 45, that is 1 by root 2, that is 0.707, and so on. And thirdly, we discussed about the sine 60 degrees, that was root 3 by 2, and that is approximately equal to 0.8660254. And the first for loop was the incremental value of the 0 to 90 degrees for the sine function. And accordingly, it printed out each of the values for the sine angles, starting with the value 0, 1, 2, 3, 4, corresponding to the angles. And we know that when it reaches sine 30, it will be 0.5. And similarly for sine 90 degree, it has to reach the value 1. And accordingly, we get it. And so when you take the tan angle, we know that tan 0 is 0. And tan 45 has to reach up with the value 1. And we get it. And for tan 90, it is going to give an infinite value. And the infinite value is represented by these. The sequence of this representation of numbers plus 16 is 16, that represents an infinite quantity. And then the third fourth loop was representing the cosine function starting with the angle 0. And we know that cos 0 is 1, then followed by the cos 60 has to reach up with the 0.5 value. That is exactly the reverse of the sine 30 degrees. And when we reach the cos 90 degree, it has to diminish with a very small number, and it's taking up this quantity that is approximately equal to 0 value. So this is how we can see how the math function can be used for the trigonometric identities.